Good afternoon and welcome to this A2EP webinar on helping commercial and industrial businesses get to net zero. My name is Jared Leake and I'm the CEO of the Australian Alliance for Energy Productivity. A2EP is much easier, of course. May we begin this webinar by an acknowledgement of the traditional custodians of country throughout Australia and their connections to land, sea and community, and pay our respects to their elders. For myself today, I'm coming to you from Darramurrugal lands in the northern suburbs of Sydney. This webinar is supported by our wonderful broad selection of members. This is our fantastic growing network, and all of these members share our vision of improving energy productivity across Australia and decarbonisation. And without this set of members, we wouldn't be able to bring you such webinars that we have like today. Just a little bit of housekeeping. Yes, this presentation will be recorded and uploaded onto YouTube in the next couple of days, and the presentation slides shall be put out to those that are registered. We're definitely going to have time for questions today, so please get them ready and pop them in that Q&A box down the bottom, or feel free to have a little sidebar using the chat function there. But either way, let's keep this nice and interactive, and the more questions the better. You've got some fantastic consultants ready to answer your questions here today. This is the A2EP team, but I'm flying solo today. Just here with the panel members. So none of the team joining me there today, but they will be on future webinars for sure. So the topic for today sounds pretty broad, but we are going to start narrowing it down straight away here, because this is going to be a discussion today about electrification. It is the major pathway for getting to net zero in commercial and industrial, despite this recent submission of the AEMO's ISP really not acknowledging a lot of usage for industrial electricity at all. And we think that is grossly underestimated. So it is the main pathway, electrification. And combined with that, we have this excellent program coming from the Victorian government supporting electrification studies. And I understand they're going to be rolling out any day now, and we'll hopefully see 30 or 40 large gas users in Victoria have an electrification study done for them. And we've done a lot of these studies ourselves and over the last few years, and we know that there's usually often a couple of flaws that happens with such studies. One is the baselining and data and making sure certain grants and optimized for the projects that come afterwards. And two is the electrical supply that is associated with that study and how well optimized that is. So if you combine those together, and also with this trend of dramatically falling battery prices, with lithium-ion batteries really coming down, we see this as a really important thing to be talking about. And so, without further ado, joining me here today on the panel, I have Andrew Ely from VIOTAS. Andrew is the Director of Sales and Operations there. Welcome, Andrew. We have Matthew Tapp, is the engineer, economist and NEM nerd at LGI. Let's come back to the NEM nerd in a second. And Aaron Jenkins, who is the General Manager, Energy and Carbon Services at ecovantage. Gentlemen, welcome this afternoon. And since we have a self-confessed NEM nerd, Matthew, quite an interesting time happening on the NEM. We've got the wind records being set. We've got negative prices in the middle of winter in Queensland. I imagine you're enjoying the latest data coming through.
Definitely. Volatility is something that I don't think is going away soon, and probably something I'll end up touching on later, but different types of volatility mean different things. So we've had record levels of wind generation recently, and a couple of weeks ago, record minimum wind generation through the NEM. So renewables are great, and they're a great outcome for the industry as a whole, but they introduce problems we've never had to think about. So how do we be adaptive with how we produce and consume that energy is going to be the key to all of that.
Got that right. And Aaron, you're seeing some interest on that and the impact on LGCs.
Yeah, that's exactly right. The more that's created, obviously, there's a big price supply and demand metric that goes into LGCs. There's compliance, but there's also voluntary buyers. So the more we see entering and the more volatility we see into it, it changes LGC futures quite a bit with the trading. and then that flows into the business models that we'll talk about later of projects.
Yeah, perfect. And everyone, I regularly get this, and we have these discussions of where is Australia poised as this sort of renewable energy superpower, and I suggest it's not in the construction of new renewables at low cost, because our construction's so expensive here. But it's more about how well you utilize that. Are we the best at managing and orchestrating a grid and orchestrating industrials and things? So yeah, exciting times. Aaron, you've got a bit of a prezzo for us. I'm going to stop sharing and I'll ask you to share your screen. And Aaron, you're coming to us with a fairly decent background in renewables, 17 odd years, covering energy audits and certificate creation and the like. So dare I say, you know what you're talking about in this area. And we've chatted about this in the past, and we've seen too many cases where opportunities have been missed in this space. So please take us through and give us a rundown of what's happening in this area, and so that we can stop others missing such opportunities. Over to you, Aaron.
Yeah, thanks. That is, start off with the worst case scenario. It's nothing worse than telling people they missed out by that much. So today we're going to be focusing on measurement and verification, and how that benefits the decarbonisation of commercial and industrial businesses. Bit of a background as to why that is and how it works. We'll talk about who ecovantage is, what the certificate programs are talking about, and then how we can leverage those into those measurement verification or M&V claims, the different options we've got for putting those around, and then some of the key considerations that we need to look at when doing it. And then a bit of a quick summary on certificates versus grants, because there's often a bit of a concern about stability and what the differences are. So we'll cover that too. Bit of background about ecovantage, who we are. Founded in 2007, 70 of us across the country over 4 states. We've been fortunate enough to be able to work with other businesses and households to, help deliver over 10 million tonnes of carbon abatement since we've started. So it's a nice little milestone we just hit recently. And at our core business, we are what we call an ACP, or an accredited certificate provider. So a large part of what we do comes back to how we can create these certificates, whether they be a carbon credit or an energy efficiency certificate, and then how we can use those best to help businesses decarbonise and, again, get back to that 10 million tonnes by 2030. Or right now, what are we doing? Again, what's the next target? How do we go bigger? Certificate programs that we'll be touching on today, primarily in Australia, you can sum up all of your certificate programs into 3 categories. You've got your deemed certificates, which is kind of your upfront calculated, assumed certificate quantities. You've got your measured certificates, which, as the name suggests, you've measured it. These are things like your LGCs for your large renewables, etc. You measure, you know how much you've created, then you create certificates on top of that. And then we've got measured and verified certificates, which is what we'll spend most of today talking about. What M&V actually is and what that means is you create a baseline, like what Jared said. Sometimes you go into these studies knowing where you're coming from. It's hard to know where to get to if you don't have a reference point from starting. You can't set goals and targets and compare yourself if you don't have a baseline. So that's step 1 in an M&V process. If you look at the diagram there, you've got your baseline energy there in orange. You've got then a vertical dashed line. That's when, let's say, the upgrade occurs on site. Now that could be a large, more efficient BMS system, HVAC upgrades, switching from gas to electric. There's a multitude of technologies that are eligible under the various programs that we can do this. And then you've got your green solid line down the lower there. That's the new energy usage of that site, much lower. Now, what an M&V process does is it uses things like site activity, weather conditions, etc., to then model what energy usage would have been like had those upgrades not occurred. And the gap in the middle, basically the shaded green area, that becomes your savings. That's what you've measured and verified would have happened if you hadn't taken action and deployed that decarbonising upgrade, that technology, that renewable power system, whatever that case may be. And that's then what we create our certificates from. Now, a couple of examples of what those certificates are, because primarily they're often used for a revenue stream, right? They're used to increase the business case or bolster the business case of these upgrades, shorten the ROI, increase the net present value, etc. So an example of that is a HVAC upgrade that we've been involved with in a manufacturing environment. They upgraded multiple 90 kilowatt package units, replaced these with indirect evaporative cooling units. They also installed some resistive electric elements for the heating period of the year as well. The reality is they saved about 750 megawatt hours a year. Without certificates, the cost of that upgrade would have resulted in a ROI of about 12 years. we're able to shorten that down to under 8 by the creation of certificates. So year 1, they perform it, they outlay their capital, but year 2, they get a large chunk of cash, a couple $100,000 in this case, which drastically shortens the payback period for that upgrade and supports the business case. Similar example again, if we look at a BMS in a shopping centre that we've been involved with, this is just about efficiencies, right? It's just about managing what they do have smarter, better, more sensors, more inputs, making sure the facility is not running when no one's there, etc. Fairly significant capital outlay, as is often the case in large BMS systems, over $1 million. Without it, they were looking close to 11-year payback. With it, almost half that, 6.5 years. So repeated story, but basically the good thing about M&V claims is that you're not only proving what you did was effective. So if you have multiple sites, you can learn, repeat, scale, microanalyze, it's all independent, but also the programs that they operate under reward positive activity. It's not a case of greenwashing or anything. It's measured, verified, proven, tested, and then independently examined. Another one talking about heat with a little logo in your screen there, Jared. This is process heating in a manufacturing environment. This was gas to electric. So they changed a lot of their systems to avoid the need for heat as part of this. And so again, this got $1 million outlay, shortened it from 8.5 years down to about 6. So again, if you can get 20-30% reduction in your return on investment, that's a pretty solid outcome. The big thing with all of these M&V claims though is that if you don't know where you're coming from, you don't have a baseline, very, very hard to do anything. And then if you don't track what you're doing, very, very hard to prove the improvements that you've actually achieved. So we've got a couple of ways that we can perform a measured and verified approach. There's 4 methods under IPMVP, which is the international standard that all the Australian creation methods reference and interpret in their various ways. Option A, B, C, and D. Now, option A and D, they're not really eligible under any of the programs in Australia. So we won't come over them. They're not what's used. What we do have is the 2 primary methods within Australia, which is option B and option C. Now, I'll start with option C and then I'll go back to option B and you'll see why. Option C is you look at the whole facility. So in that scenario, we might measure all of the electricity coming in through the NMI point, the gate meter, or multiple NMIs if it's a large facility. And if the energy saving measure or the decarbonising upgrade creates a saving of more than 10% of that meter, we can use that as a data source. And we can go, great, used to be 1 million megawatt hours, now it's 800,000 megawatt hours. We've got a big chunk, we can use that and analyse that gap in the data to create our model. But if it's less than 10% under those standards, it's considered white noise. It could be from a host of things, which is when we then default to option B. Now, option B really relies on specific submetering, and that's because you might be doing a significant energy upgrade, but it's not going to create 10% of your gate meter or your total site's energy usage. Now, that could just be because your site is huge. You have a massive energy appetite, and even though you've only made 3% difference, that 3% might be the same as the neighborhood behind you. So that's really when you start looking at things like option B, when you need to submeter and isolate. And the value of a submetering goes beyond just the certificate claim. You've got maintenance, you've got, the ability to compare different production lines and so forth. I'm just flagging it's a lot more than just money and dollars when it comes to certificates, and a bit of a fan of submetering. An example of submetering when we go into this is exactly that. So a very large steelwork site that we were involved with an upgrade on. They had 80 of their high wattage high bays upgraded to LED. The difference is those high bays were on average about 1,000 watts each. They ran 24 hours a day. If they had gone through, this was in New South Wales, if they'd gone through the deemed certificate creation methods, which are available for commercial sites in New South Wales, they would have been able to have about 1,200 ESCIs or energy saving certificates created under those deemed methods. Market value at the time of installation of those, not today, was about $39,000. What we found when looking at it, because the lights were running so often, 24 hours a day, and because they were quite high wattage, that if we went through a measured and verified approach, or as the New South Wales program refers to it, PIMV, we had to create a baseline. So we've installed submeters, created the baseline. In this case, it was for 60 days because there's no seasonality. They were 24 hours a day. It doesn't change no matter what time of the year. we were able to increase the certificate creation to 4,747 energy saving certificates. So to put that in context, the market value of that was $155,000. So quite a big disparity. The sub-metering was fairly simple. It was fairly easy to deploy. It was several large lighting control boards, simple CTs, remote read, integrate that into the site's existing systems. The net benefit after sub-metering installations and the increased certificate creation, yes, they had to slow down the upgrade by 60 days, but there was an additional financial benefit of over $100,000. So then they've got on top of that, they can see that sub-metering because it's 24 hours a day. If the wattage drops, it means the light's blown. They've got all the additional benefits that come with that and the analytics that can go there. But it just shows the difference of not just assuming what you can get, thinking, working with someone who can understand it, unpicking it and establishing the best way forward, and also the value of sub-metering. This site here, this claim wouldn't have touched 1% of the site. So option C was never an option here. And just a little bit of a point, if you're in New South Wales, you've got a couple of days left. There's a decent grant there. We don't get anything out of it, but if you can get 100 grand in your sub-metering, it means we've got a whole lot better chance of helping you with some of your option B claims coming up in the future. So have a look at that. Another key consideration when you get beyond sub-metering though is also newness. And that's what Jared and I were talking about at the beginning about there's nothing worse about someone just telling you about this exciting new project they're performing and you ask where it's up to and realize that they've missed out on really most or all of the certificate streams that could be attached to that program. And therefore, you know, these business cases start being told, oh, it's not actually worthwhile doing. It's not that good. The reality is if you don't leverage everything at your disposal, you're never going to get the best outcome. True in most things in life, including certificate claims under measurement verification methods. So various different programs we operate. Primarily, you've got federal program, ERF, that creates ACCUs. That's all over the country. Victorian Energy Upgrade Program creates VEECs in Victoria, as the name would suggest. We've got the New South Wales Energy Saving Scheme. In South Australia, there's the Retail Energy Productivity Scheme, LGCs nationally, and then there's also international programs such as VERA, which can create VCUs. Now, they all have different newness thresholds. One of the hardest ones to comply with being the federal ERF program, because newness basically means if you don't tick this box, you're not going any further because you obviously didn't need the support of the program, is the way they're written. Now, under the ERF, if you haven't had your project lodged and approved before final investment decision is made, which is very, very early, just flagging that in the commercial process, this almost becomes hard to achieve or counterproductive. If you haven't got the program registered with someone like us and it's all said and done with the regulator, before you reach final investment decision, you're not getting squat. That's it. So that's a tough one, and I start with that one, and a lot of people tell me that newness is a very long four-letter word because of that, but we have to say it. In Victoria, it's a little bit more comfortable where it's before construction work begin on the upgrade. So before tools and spanners are on site, as long as we've got the project registered and approved by the regulator before that date, we're good to go. From experience, typically, 4 to 8 weeks, and you'll get that done by the time we do our work and the regulator does their work. It's not too unrealistic. And then in New South Wales and South Australia, it's much more generous. It's until the project is finally commissioned. Vera, again, they've got far more leniency. It's within 2 years of the site being energised. And with LGCs, we don't have a stricter newness requirement, but it's about if your site isn't registered, and LGCs is primarily about generation certificate, hence the G in LGC. If your site's not registered, anything it's doing isn't being recognised. So that's a case of get your large wind, your solar, your whatever the case is, your biogeneration set up and registered, because otherwise whatever it's doing isn't being recognised on a certificate front and you're just leaving revenue on the table. Data integrity is the other one. Like I said, with sub-metering, the same can also be with the quality of the data. If you're measuring daily, monthly, there's a huge difference in accuracy factors we apply. And the same as also just having a system to store it in. If you don't know where it is and what you're doing, things like having a quality energy management system as part of your business, whether that be actual software or just processes within your company, well worth the look, because when we do a measured, verified and claim, we're not just looking at your gas and electricity site meters. We might be looking at the sub-meters. If they're sub-meters, we look at where they are within the facility and how that data interacts with the rest of it. Does the cumulative sum of your sub-meters equal your gate meter? We look at meter grade, accuracy, the losses, the parasitic losses, sometimes what goes into the system. If it's anaerobic digestion, there's a lot of energy that goes into turning the digestate, keeping it warmed. Even if it's a solar system, people don't realize the solar system does have auxiliary losses. Inverters need to stay connected to the internet overnight. There's all sorts of things that go into that. And then some of the other things that people don't tend to think about when you're doing a measured and verified claim is the non-energy metrics of the site. So that might be feedstock going into a digester. That might be the weight and volumes of waste being turned to energy. I use the example of spoons in a spoon factory. We have to tie the energy into the site's behavior. So it's very well and easy to say, I used to use 100 megawatt hours a year at this facility. Now I use 0. It's because you turn the lights off, you're not using the facility anymore. So that's not an improvement in efficiency. So we need to tie it to how many people are working at their desks, how many spoons did that spoon factory make, how many tons of raw material did the facility process. So again, being able to have those kind of metrics tracked and provided can be the difference between having a claim that's eligible because it's accurate and a regression analysis proves that, or ineligible, or in some cases rounded down heavily because there's a low confidence factor. So data, you'll get sick of hearing that word if you go through a measured and verified claim. The plus side is you get paid for it. So you got to make sure you get it right. And it also helps future investment decisions and you understanding your business better by knowing what's going on within it. And the final slide, and you'll be free of me, is the difference between certificates and grants. We do hear quite often the other thing, other than finding people came in too late, is that they haven't put certificates into their business models because they go, oh, look, who knows if it's still going to be there. We don't want to factor it in. It might be too good to be true. Which can be true in grants and other various funding metrics out there, but just a bit of a flag. If we do a quick comparison of certificates versus grants, some of these certificate programs have been running since 2019. And if you look at New South Wales, for example, that's in legislation out to 2050. South Australia and Victoria are out to 2030. The ERF, federal program, there's actually no end written anywhere for it. So there's longevity in these programs and they've been running for over a decade already in many cases. Whereas sometimes a grant might be open for 6 months, 3 months until funding is exhausted. And that's the difference again with certificates versus grants, is that there's capped funds in most rounds of funding if it's a grant program. If it's a certificate program, most of the certificate programs that we operate in, South Australia being slightly nuanced, they're a live market. That you've got supply and demand, like we were talking about LGCs earlier. You've got voluntary participants, you've got mandatory participants, you've got speculative traders. There's a lot of capital in there is the point I'm trying to make. You've got most of the energy retailers in the country involved in these programs, and they can buy what they need for this year or for next year, as you can with large emitters or for investment funds, super funds. So there's a huge quantum involved in that. And look, the problem that you've got with some of the grants is they're really hard to apply for, and sometimes the internal resources required for that aren't available. The good thing about certificates, I guess, is you've got people like us where it's our job to make sure facilities get everything they can. So we do it, right? We're motivated to do it. If we don't do it, you get nothing. We don't get paid. We've got to get it done. And the nice thing about certificates in general is that they've been through Labor, they've been through Liberal, they've been through pretty much every major government configuration in Australia you can get. And they're still here. So politically, they've proven to be quite a robust instrument, and they've been quite stable in helping support investment and decarbonisation. So 30-second summary, but just something to think of. Hopefully it gives you a little bit of confidence to put these things in your business model or to reach out to us and help us figure out how to do it. Brilliant. And that's it.
Thanks, Aaron. And yeah, got to echo that one. Gives them confidence to put that in that CBA and what have you. Certainly the certificates should be in there. Grants, you might have a little bit of a question mark. There's still plenty of longevity in things like arenas, ITS and what have you, but yeah, absolutely good to have in that CBA. While I'm waiting for a few questions to come through from the audience, I'm just going to hit you with a couple. You did mention, I saw that M&V versus deemed method. You saw an extra 100 grand there. And you said a 60-day delay. You also get a delay in the cash as well, though, don't you? So that can be a bit of maybe an issue.
Yeah, so that's true. So depending on how long the measurement period needs to be for a measured and verified claim, it comes down to seasonality. So if we're measuring a site or a load that's being upgraded that has heavy seasonality to it, you might look at, say, the energy usage on a vineyard. You've got vintage, huge energy usage, crushers, chillers, heavy equipment, and then it goes dormant to largely storage and retail for the rest of the year. So sites like that have a very big seasonality to them. You need to measure that for a year so we get a full operating period, or if we're verifying output of solar system, same deal, summer, winter, autumn. So in that case, we need to measure for a year and then lodge the claim to create the certificates, which can take 3 to 6 months. If it's a case of, say, that lighting upgrade where they're 24 hours a day, we can measure for 60 days, measure for another 60 days, then lodge it so you'll get paid within a year.
Yeah,
so the downside of M&V claim typically is you have to wait for your money quite a bit longer than deemed. The upside is projects of scale, projects of complexity, anything that's a bit bespoke, doesn't typically fit into a deemed box. So you can't get it as an upfront certificate incentive. And that's really the point behind the measured and verified certificate programs, is rewarding technology agnostic solutions and rewarding complex solutions that you need to see to believe and quantify.
Yeah, absolutely. Good. And that's why you're deemed suitable for smaller type stuff.
Correct. Yeah.
But if you're looking at that, I'm going to call it somewhere around about 50 grand, you say, this really likely to be an M&V one.
Yeah.
Another one there I'll pick up on is the option B or C. C is like a ring fence the entire site, and see how that changes. Any commentary on what sort of sites usually go for B or C? Because I thought C, you've got still needs a fair bit of data, and data quality being important, as you said. But maybe that's a little bit harder to establish. Who goes for B or C?
Look, your very large sites, you almost end up having to go option B. If you look at a huge industrial facility, to make 10% of that through any one activity is very hard to do. Whereas some of your smaller commercial industrial sites, like a medium-sized shopping center, you can go option C relatively simply. And in that scenario, they might have 2 or 3 feeder NIMIs. We can combine them, draw a measurement boundary around the lot, and merge them into one measurement boundary. But that's, again, only useful if they're doing something significant. So let's assume that you've got a large shopping centre that's never had solar put on its roof in Victoria. We can go down that route. However, if they were upgrading just a wing and changing the package units on that, you'd probably either want to go for option B or option C with just an isolated lens of that section if it's got its own NMI for that wing of the shopping centre. So it really comes down to site-specific knowledge, and also with all of the measured and verified programs, you really got to sit down with someone who knows what they're talking about, describe the project with them. Here's the brief. Here's what we're going to achieve. This is what we think the outcomes will be, and then decide the best approach. So planning pays off tenfold in these things.
Gotcha. No questions come through just yet. And if people wanted to just have a chat with Aaron after this presentation, by all means do that. So I'm going to hit you with another one, and we've spoken about this. This is a doozy that I'm getting a few mixed messages on. So we're at a site, they want to electrify, and they see that maybe not enough capacity coming in from the local distribution network. So, okay, I'll put in solar PV, and that means I can get STCs or LGCs for that. And I'm going to use that to reduce my gas consumption. I'm getting a few different messages on whether that, now that I've reduced my gas consumption, I could potentially get ESCIs or VEECs on that as because of the lower CO2 emissions from not using gas. Where do we stand there? Is that double dipping if I get STCs for the solar PV and I get ESCIs or VEECs for the or ACCUs as well for the getting off gas?
I think the key point to that answer is what you kept saying of ESCIs or VEECs or ACCUs. They all have different answers to them. So if you're in Victoria and you're doing that exact upgrade, most people would just get VEECs for everything. They wouldn't bother about the LGCs, bundle it all into one M&V claim and measure the output of all your changes at once. VEECs are at historic highs. They're over $100 for the price of carbon at the moment. So there's a really strong business case to measure everything as a VEEC and go that way. And you can't double dip. That's kind of the golden rule with all these programs, is you can't double dip. Whereas if you're in New South Wales actually incentivizes degassification better than Victoria under the measured and verified approaches, because they look at it on an energy level as opposed to an emissions level. But however, they don't recognize behind the meter solar systems under their program. So what we'd actually have to do in that situation is draw 2 measurement boundaries, one around the solar system, STCs, LGCs, depending on the scale, one around that gas to electric heat pump type scenario. So And ACC uses a similar story. So again, it really comes down to knowing where it is, what you're trying to achieve, how you're going to do it. It just starts like a broken record of planning in advance as someone who knows what they're doing.
Aaron, I think you did a great job of answering that question really well, but also convincing me that we need to employ and use experts to help us through that advantage. So thank you so much. Good. All right. Let us move on now, and let's talk about electrification. And as I said, that's the seems to be the main trajectory for where industry and commercial is obviously headed. But so many times we're seeing that people aren't getting the most out of their electrification projects. One of the best ways is to get the value add is look at demand response and incorporate that in the design phase, and think about these options of what can be done there. To take us through that, we've got Andrew Ely, Director of Sales and Operations from VIOTAS, and let us know what's available here, what can be done to really optimize that electrical supply, and how you can participate. And then we're going to go into hear from Matthew Tabb, who's going to take us from LGI, who's actually done it. So Andrew, over to you. Take us. I can see your screen. Just got to go into presentation mode, and we'll let's see how this is going to help with that cost benefit analysis when we're electrifying.
Look, thank you very much for the time and the opportunity, Jared, to run through demand response and the opportunities it presents to our sort of customers. So to start with, I'd like to cover a bit more about VIOTAS and who we are and what we do for context, and then how that sort of translates in helping our customers on that transition to net zero and supporting that transition. And then touch on one of our most recent sort of case studies in terms of the battery energy storage space, and hand over to Matt Tabb from LGI to cover that in a little bit more detail, as that project was with Matthew. And so at a high level, like I probably don't need to tell too many people on this telephone call that the energy market is evolving, and it's evolving to enable consumers to participate in the energy market and to generate new revenues. So VIOTAS is a market participant. What that basically means is we can help reward commercial and industrial businesses for flexibility when they use, store and generate their electricity. And we work with a range of businesses across the country and the globe to achieve this. I might just jump through the next one if that's okay, Jared. So in terms of us as an organisation and what we sort of do, we provide an end-to-end service for our customers to get them in and earning revenue as fast as possible. That extends from doing an evaluation of the opportunity all the way through to getting them into market and participating. We take the challenge and the issues and the time and the hassle out of that for our customers, as we're the experts in this sort of space, and it's only really a handful of hours across the course of the project with any given customer to provide us some information, to provide some input, and then move them into the market and earning revenue. We're able to leverage our global experience across a diverse range of asset types and also industries, so we know what to do and how to do it and get them into the market earning money as fast as possible. One of the keys for strengths that we sort of have as a business is our customer focus. So at VIOTAS, it's our core business to maximise revenue for our customers and to sort of share that revenue. We share value, so therefore the more money that our customers make, the more money we make. So it's in our business model to maximise the revenue for all parties. We're also backed up by an in-house innovation team. So we have a dedicated team, about half the company, who build all our products and services from the ground up. That basically means our customers are there ready to jump in as soon as there's a new market or a new revenue opportunity. We're well placed to provide that to them. An example of that was the new 1 second very fast FCAS market that came in late last year. All of our customers were in and earning revenue in that market from day one. So it was something that was very, very beneficial, as from day one the market prices were very high, and they were able to capture those for the duration of that high price period. The other key set of strength that we have as an organisation, sorry Joe, just back a little bit, is that we're vendor agnostic, and this actually feeds into the LGI case study that we're about to sort of cover in a little bit later in the presentation. What that basically means is we're able to work across any supplier of any type of equipment, whether it's a compressor, a pump, a battery, as is the case with LGI. So that puts us in a good place to plug and play with whatever the customer is planning on doing and how they're planning on doing it. On to the next slide, thank you. So I think this is where we sort of start to talk about, well, what does that mean for our customers, and how do we translate that into something that helps them on that journey to achieving net zero? So first and foremost, what we're able to do is to unlock revenue from that flexibility when they use, store and generate electricity to provide additional revenue stream and investment in the equipment. And that could be towards new, more energy efficient and carbon efficient equipment. And we could also add on to the business case. I think we're sort of talking about, Aaron, and how he can feed into those business cases with the certificates. We can also feed in a new revenue stream into those business cases that can help to justify that investment and help the customer to transition into a more energy and carbon efficient future. The other sort of way that we sort of help customers to with that transition to the net zero future is around the support for renewable energy. And I've got a video just up there. Sorry, Jared, if we could just jump into that. That sort of unpacks a little bit how that works.
What is demand response and how does it support greener energy? Wind and solar energy are key to decarbonising electricity. However, even when wind and solar are in abundance, power plants are kept running to counteract sudden fluctuations on the grid. With VIOTAS demand response technology, large electricity customers are paid to automatically adjust their electricity consumption to counteract these fluctuations. Our customers allow more carbon-intensive power plants to be turned off and more renewable energy to be turned on. It's a win for renewable energy and a win for our customers.
So what we sort of show here is some of those target industries that we sort of look to partner with. And so what it really underlines is based on our local and global experience that we work with a diverse range of assets across a variety of industries. It could be from data centers, chemicals, pharmaceuticals, cold stores, and water authorities. So we have a diverse range of experience across a large range of industries that we can take into the customer. So if there's an opportunity, we'll be able to find it and we'll be able to make it happen and actually get them into market and earning revenue as fast as possible. So this is just a quick sort of overview, and as I said, Matthew Tapp will be coming up next from LGI to run through the case study in a little bit more detail. So I do not want to steal Matt's thunder by any stretch, as there's some absolute gems coming through, and there'll also be the video case study which we'll share, which gives a very good overview of that sort of opportunity. But at a very high level, what we sort of had was a situation where we approached LGI, who are a landfill gas operator, and they are looking at putting in a new BESS on one of their sort of sites, and they're looking for a partner who could help them unlock the rarest revenue streams that can come from such assets. So we went through a detailed discovery sort of process to work with Matt to understand, what the opportunity was and where we could add value. What we identified in this instance is that we could help them unlock what we call frequency services revenue streams from market participation of that BESS. We then sat down and went through a detailed technical evaluation. So what was the site, what was on site, what were the operations, what did we need to do to help the customer to achieve and unlock those revenues? We came up site-specific design and solution. We then worked with the team to integrate it into their existing sort of site, test it and get that asset into the market. And it's currently earning those revenues for Matthew and LGI. I might sort of leave it to there and probably open to questions.
Excellent. Thank you so much, Andrew. Let me just have a quick look at the just some commentary there rather than questions. So it looks like we're going to go straight through, and I think that's appropriate. We'll just go straight through into the presentation from Matt. So Matt, if I could get you to share your screen. Well, I'll give you a quick intro. I've already introed you as the NEM nerd, but also an engineer and an economist, and really excited about innovation and development within LGI. So I'll hand that over to you to take us through how you've implemented this VIOTAS solution. Matt, over to you.
Perfect. Thanks, Jared, and thanks, Andrew, for the nice segue. Again, as always, probably everyone does a quick overview of the business, give some context. So LGI is a landfill gas, carbon abatement, renewable generator business. We focus on regional, smaller landfills, traditionally with local governments. We have some private waste operators as well. And our focus is working with waste operators, landfill operators to manage the emissions profile of their facility and actually produce either a revenue stream, just offer a service, or in the best case scenario, actually produce renewable power with that process and get the best outcomes. So we have kind of three streams to our business. One is more in the service delivery infrastructure lane. So working with operators to get access to that gas, to get wells installed and extraction occurring, operation of assets, the kind of more generic side to managing a waste stream. We then have a second stream, which is about greenhouse gas abatement. Aaron actually mentioned ACCUs previously. That's kind of that pillar to that area. So there is an ERF methodology for the combustion of landfill gas, which is predominantly methane. And methane's 28 times worse for the atmosphere than CO2. So converting methane into CO2 is a good outcome. So we then use either generation assets, recip engines, or just actually a flaring unit. So it's a pretty simple device, but a very effective one. And then that last stream is where we can produce power, working in the NEM with that additional revenue stream, optimizing operations within the NEM, and trying to get the most value out of all of those potential revenue streams. So a quick overview of our footprint. We've got 31 sites across the East Coast through Queensland and New South Wales, varying from small flaring sites, consuming about 100 to 200 cubes of landfill gas an hour, all the way up to our largest site in Canberra, which is 4,000 cubes of landfill gas. All in all, we produce about 100 gigawatt hours worth of energy a year and about 100 million cubes, apologies, of landfill gas combusted. So some very high level metrics, but we'll kind of step into what that case study is in this case. We saw a need for dispatchability. We spoke earlier, Jared, about price volatility between different periods of the day, that low daytime pricing, that high evening pricing. We're a generation asset, so we're exposed probably on the other side. We don't like negative pricing, we like high pricing, but it's that same interaction where if you operate in a flat level, you're going to end up getting exposed to the average. But if you can flex and you can use those assets in an intelligent way, then you'll only do better than everyone else. So that was kind of our focus probably 2 years ago, looking at what our generation assets can do. Can we flex them? How do we work with landfill gas to get the most out of that fuel source? But it then became very clear that battery pricing was coming to a point that was more viable. I think in 2019, AEMO had the cost for storage at $2,000 a kilowatt hour. It's now probably closer to 700 or 800, so we're already halfway down that technology curve. That's only ever going to help projects like this, which was to install a battery with our landfill gas generator and actually flex that asset. So this slide here really just talks to the complexity of it all more than anything, but complexity is also where value often lies. If you can break it apart, simplify, and tackle each of those complex things one at a time. Again, work with a party that, like Aaron said, someone that's the expert, they've already broken it down. So get them to solve that individual problem for you and stack those opportunities. So for a battery, we're obviously playing in the spot market. We're charging when price is low, discharging when price is high. We're able to work with that bidirectional flow and that rapid response to really leverage 5-minute pricing. So as much as we boil down our energy costs into monthly charges, daily charges, the market is every 5 minutes, 288 times a day, you get a new market signal. Should you be importing or exporting? How should you be dealing with it? That's a very fast learning curve for lots of businesses. So batteries probably give you the flexibility to exist in that. And that speed to market, that rapid response enables you to actually stack multiple revenue streams. Multiple revenue streams is complication again. So how do you optimize a problem with an asset that will respond in several cycles of the grid, but also you're trying to optimize 4 or 5 different revenue streams. You're trying to consider, how do I operate this asset without impacting my normal business as usual operations? I don't want to have a battery take my processing facility off. So how do I de-risk my core business? Again, automation is going to be the key to that. It's know your problem, solve it in advance, spend a bit of legwork and brain power in advance, and really scope it up. You'll often find some gems hiding in there. So at Bunya, we started the long process of trying to connect an asset into the NEM these days about 2 years ago. So that was the initial interactions as a generator with a DNSP, looking to get a hybrid facility. So not just a bidirectional inverter like a battery, but actually co-located with a synchronous machine that has complexity that had never actually been done with the DNSP we were working with. So how do we work through that from a technical level? Once we were able to work through that, we then were able to install it. This photo that you can see is from about November last year, and by January we're actually in operation. So moving through that process, once you've ironed out and worked through all the hard engineering steps, the design steps, they are actually reasonably easy assets to install and get functional. You just have to step through that process. Ultimately, it's a 5 times increase in our dispatchability at this site. So that bidirectional asset really doubles down on our ability to respond. We can import up to 1.2 megs and we can export up to just shy of 2 megs. So that's a massive change in our ability to respond to pricing, but also probably key to this conversation, start engaging in FCAS. So we're actually able to operate in both the raise and the lower markets. Some context probably to FCAS is there's 8 markets of contingency FCAS, and we are a battery like this, and working with VIOTAS with that speed of response, we can get all 8 revenue streams, all 8 markets worth of value. So that is core to the financial business case of these types of assets. We then spent about 12 months while we were trying to get the asset connected, writing a control system to make all of the magic unicorns do what they're meant to do. So that was key to our ability to operate in the NEM, take spot pricing, form predictions of pricing, and make a decision in advance for what we're going to do so that we can then stack FCAS in, defend contracts like swaps and cap contracts, all the things you already have to do as a load to firm up your supply of energy. Generators also do to firm up the risks. If all of a sudden next week we end up, or in a very good way from a renewables perspective, we end up with all of this wind and we have negative pricing during the day, lower suppressed evening pricing, well, that may not be viable for a project. So you have to lock some of that revenue away. We have to consider all of that in those decisions. So very analogous to a load, we just see pluses on our outgoings instead of the negatives for imports. And stepping in probably more to the interactions with VIOTAS. So ultimately, we selected VIOTAS because of their alignment with values. We also have a team dedicated to internal design. We design, build, own, and operate these facilities. So we needed a group of people we could work with that weren't just pulling off-the-shelf equipment together and trying to make it all work in a cookie-cutter approach. We needed a group that we could ask complex questions with, build it into our SCADA and control system. We actually spent quite a bit of time with VIOTAS developing a faster means of communication because we're making decisions every 5 minutes. We can't be relying on some operators and a phone line or an email. So that was that learning and development of a scalable approach, something that we can go and roll out on every site. And kind of a question I feel should be asked a lot more, which is why didn't we do it ourselves? Obviously, I've just said we have the capability to do a lot of those things in-house, but registration, dealing with AEMO, bidding, 24/7 operations, those are things that we're not currently geared up for. Those are things that very few businesses are. And you don't want those to be a distraction. You don't want to have to double your workforce just to be able to keep doing what you did and gain access to one more revenue stream because it won't be viable. So that was probably core to us going out chatting with VIOTAS, getting them on board, because yes, of course, we could have stumbled our way through it and unlocked a different level of value, but at what expense? And that's a question that probably needs to be asked up front. And again, call to Aaron as well around, you can solve a lot of problems yourself. It's what's that opportunity cost? What didn't you do because of it? And yeah, probably it for me.
Thank you so much, Matt. You are reminding us of the study and the hopefully report that we'll have issued soon on ESCO energy service companies in Australia. And and through our research, we found that to operate your own solar PV field, no worries. Do that yourself, plug it in, away you go. As soon as you flip over to that hub with a battery, which is where it's all headed, then to maximize the value of that battery, very hard to do it yourselves. And you guys are somewhat an energy company. You're used to exporting energy, but you flip over the battery and all the different services you need to do. Not for you.
Yeah, and it's a complication that we probably, as the NEM actually hasn't learned yet. Again, I'm going to go NEM nerd style, which is we ultimately, you see lots of batteries operate in that blocked period. Let's charge during the day and we'll export at night. We'll put a window over it. We'll sit there, and between 10 and 12 price is going to be cheap, so we'll charge. And most businesses that will probably justify the battery. It's not unlocking all the value, but it's an easy approach. So yeah, there's complexity and there's different approaches. I think the NEM will slowly get better at managing that, and that will actually make the pricing signals that the AEMO and the spot market attempt to give far clearer. Because if everyone charges in a windowed fashion and they're ignoring the spot price, what's the point in telling them what the spot price was? That's meant to be the lever AEMO has to pull, and if they kind of are not able to, then it defeats the whole purpose.
So then it all comes back to orchestration. Just
Yes.
a technical question for you. I've seen these big biogas and biomethane bladders.
Yep.
And so you can conceptually have a bit of a store, a couple of hours of biogas, and then maybe flex your gas engines up and down, say, rather than the battery. I assume you had a look at that as well, and what made you head towards the battery, if so?
Yeah, 100%. Bladders are a complication when you start getting into the detail of it. Biogas is not 100% methane. So it does oxidize. You do get reductions in thermal heating values over time. So you can store, but you can't store perfectly. What's the risks? What's the impacts? Storing gas is a notoriously complicated process. We do it at high pressure and low temp for a reason. Doing it in a cost-effective natural environment, not pressurized, not cooled, has risks. So instead, the approach we took was to flex the landfill itself. Again, the same you would with any feedstock, the same you would with any output. How do I change the time of day to limit my exposure to the thing I don't want? You make a stockpile and you try to stockpile your goods until you want to use them, and then you go at 2 times the rate you would have previously. So that is an approach that we did take, and we still do take, actually. We do flex generation based off pricing, based off revenue streams we receive at the time. All sorts of things go into that. But the driver for the battery is the unlocking of different revenue, things like FCAS, things like caps that you can defend, but also the reason we're on site at its core, we're an environmental business. We're a business that exists to manage and assist waste operators in their emissions profile. If we had negative pricing for several days in a row and didn't generate power, that would be a very bad outcome for the environment. So there's also a drive to have continuity of that service, and you can flex for a couple hours. We actually refer to it as sponging, that concept of you can fill a sponge with water, but you keep putting water in it, eventually it's going to leak out. It's not a balloon. It's not impermeable. So we are going to have that gas leak out. It's going to go to the environment. It's going to have bad outcomes. So don't let the sponge fill with water, just let it soak a bit of extra. And that is an approach that we have and still take. but the battery is that on steroids. It's not perfectly efficient, but it's perfectly responsive is probably more the point.
Good on you. Well, congratulations to you and to VIOTAS for doing such a project, and I'm guaranteed we're going to see a lot more of these. So well done for pioneering and for sharing how that's running. Obviously, very happy with the results of this, and hopefully see some excellent financial return as well. So well done. Good.
Safely say we're happy because we're building a project 10 times the size at the moment. So there you go.
There will be more. No questions have come through today. Sorry about that. Apparently we had a problem with the chat. It wasn't turned on until late there, but we'll hand out the contact details for all of our presenters today. So if you want to get in touch and ask a few more questions, I'm sure they're open to a couple there. But otherwise, without any further questions, we shall close things out. Let me just share my screen for one moment. So, and certainly thanks to our presenters there today, Andrew, Matthew, and Aaron. Fabulous insights, really help moves on energy productivity and energy costs, and so very appropriate now with how volatile things are and how much are changing. So thank you so much for sharing today, gents, much appreciated. Just to wrap things up now, hopefully most of us on our subscription list would have noticed we've officially launched that Renewable Heat Conference coming up at the end of September. We have got some fantastic manufacturing speakers lined up. So this is a knowledge sharing conference, and you're going to hear from people just like Matthew Tapp here about real life experience of biomass, biogas and electrification technologies, and all the lessons learned and what have you as they develop these projects and operate them. So it's going to be a fantastic knowledge sharing. I hope everyone here can join us at the end of September there in Sydney. Meanwhile, some other smaller events happening. We're going to take a look at biogas at the end of July in association with the Race for 2030 and the Ministry of Foreign Affairs from Denmark and their Trade Council, and have a look at a bit of policy that's happening in Denmark, which is really supporting biogas, and a few ideas of what we can do more here and research that's required there. Biogas seemed rather unloved for the last many years, has huge potential in this country. So please join us for that one. We also have our annual freight transport review, solving the freight decarbonisation puzzle in collaboration with Movement. That's on the 14th of August. It's one of our most attended webinars, so please join us for that one. The insights and the change in the last 12 months, which has happened for EVs and trucks and efficiency there, is quite surprising. And so look forward to having that webinar coming up in August. We also have our quarterly update with a member mixer coming up in Melbourne on the 20th of August. Please join us for that one for some great presentations and networking drinks. We also have looking at another deep dive into batteries coming up in September. Running alongside that, we also have our site tours, which people love and keep coming back for. We've already done 2 site tours, and one of those just last week was completely sold out. And the next one for next Wednesday, looking at Northcote Aquatic Centre and Three Ravens Brewery, is already sold out, and I look forward to hosting that one. We've also got a few more coming up at Brimbank Aquatic Centre, and looking at this PICAC training centre for heat pumps out at Narra Warren, and then also a couple of sites in the city later in mid-September. So lots of heat pumps coming at you there, lots of events, and so please do join us. Finally, as always, a quick reminder, follow us on LinkedIn. Always lots of good content being shared there, and that's the best way to keep up to date with us. So once again, to our speakers, thank you for your inputs today. Much appreciated. And thank you all for joining us. Hope you enjoy the rest of the afternoon and look forward to seeing you at our next event or webinar. Thank you so much.
Thanks,